Hello students, welcome back. I am Ncert and today we will continue with the third part of Ncert Textual exercise of chapter number 4, that is motion in a plane. Till now we had completed till 4.12. Now let's begin with 4.13. A man can swim with a speed of 4 km per hour in a still water. How long does it take to cross a river 1 kilometer wide if the river flows steadily at 3 km per hour and he makes his strokes normal to the river current? How far does he go when he reaches the other bank? Okay, so see, let's take this as the width of the river. Okay, now this is 1 kilometer wide. This distance is 1 kilometer. Okay, now man can swim with a speed of 4 km per hour in a still water. So this will be the direction of velocity. Okay, with respect to this is the velocity of the man, and that is with respect to ground. Okay, now river water flows steadily at 3 km per hour. So the water is flowing at a speed of 3 km per hour. So direction of velocity, it's this direction. This is the direction of water. That is equal to 3 km per hour. And velocity of man, that is 1 km per hour. Sorry, 4 km per hour. Okay. And he makes his normal to the river current, means he is going in this direction, exactly perpendicular. Normal. This is the river current and this is the velocity. How far does he go when he reaches the other bank? Means when he reach to other side of the bank, let's this is A, and then when he reach on the side B, what is the distance covered? Okay. So now see here, the velocity of the man is in this way with respect to water. Velocity of water is in this way. Okay, this is 4 and this is 3. So this is the relative velocity of man with respect to river water. Okay, clear? So if this is 3, VR is 3, VM is 4, that means velocity of man with respect to river water will be equal to 5 km per hour. Now, as his speed with respect to ground is 4 km per hour, means Vm is equal to 4 and the distance to be covered, that is equal to 1. Okay, so velocity, that is equal to distance by time, that implies time is equal to distance by velocity. So what is the distance? 1 km. What is the velocity? 4. That means the time taken will be equal to 1 by 4 hour to reach to the other bank. Okay, but now this was the velocity of the man with respect to the ground, but now the velocity of man with respect to river water is 5. Okay, so velocity of man with respect to the river water, now it will be equal to distance, total distance covered, d dash upon time. That means distance covered, that will be equal to vmr into time. That means 5 into 1 by 4 hour, right? Sorry, kilometer. This will be equal to 1.25 kilometer or 1250 meter. In reality, the distance covered is greater than 1 kilometer. Okay, the reason is the man is moving in this direction. Okay, but due to the river flow, he will be moving in this direction. So this is the actual distance covered. Okay, let me use red color. The red color part, this is the actual distance covered, that is 1250 meter. Clear? So this was about 4.13. So just note it down. Now let's move to the next, that is 4.14. 4.14. In a harbor, wind is blowing at a speed of 72 km per hour. The flag on the mast of the boat anchored in the harbor flutters along northeast direction. That means this will be the direction of the wind, northeast direction. If the boat starts moving at a speed of 51 km per hour to the north, what is the direction of the flag on the mast of the boat? Okay, so now let's take this as north direction, this will be as south direction, this as east direction, this as west direction. Okay, now see, the wind is blowing in the direction of northeast, so I will write down northeast. This is the direction, exactly 50% between north and east, so this will be 45 degree. Use another pen. This is the velocity of wind. The boat starts moving at a speed of 51 km per hour to the north. So boat is moving at a velocity of 51 km. This is the velocity of boat. But see, when the boat moves in north direction, right, the wind the wind experienced by the flag will be in south direction, right? When you move when you move ahead, when you move forward, when you move in north direction, the wind will be in south direction. So instead of VB, I will use the effective wind minus VB. So this is the opposite direction. Clear? Now, what is the direction of the flag on the mast? So, the direction of the flag will be resultant vector of VW and VB. Clear? So, see, if I take this as vector VW, this as vector minus VB, the resultant vector will be between this one. I can write it in this way. Anywhere. Let's take making an angle beta with VW. Okay, so we need to find out beta angle, so from that we can know what will be the direction. Okay, so for that we will use the formula for angle between the resultant vector and initial vector. Okay, I'm writing you the formula here once again. See, if this is sorry if this is vector A, this is vector B. Okay, an angle between A and B is, let's say, theta. So if this is a resultant vector A plus B, making an angle beta with A, okay, making an angle beta with A, then tan beta will be equal to B sine theta upon A plus B cos theta. Okay, in this case, what is the angle between VW and minus VB? See, this is 45. This angle is 45. So this angle will be 180 minus 45. Okay, that will be equal to 135 degree. So in this case, theta is equal to 135 degree, right? Initial vector vector A, here instead of that it will be VW, and its magnitude is, what is the velocity of wind? 72 kilometer per hour. Okay, velocity of boat, that is equal to 51 kilometer per hour. So tan beta means beta angle making it with the wind, that is VW, that is equal to B, means here VW sine 135 upon VB plus VW cos 135. Okay, sorry, I've written the wrong formula. It's B sine 35. So here this is vector A and this is vector B. If I relate it with this, so it will be VB sine theta, that is 135 degree, upon VW plus VB cos 135 degree. Okay, we need to find out the value of sine 135 and cos 135. I'm solving it here separately. Okay, sine 135, that is the mathematical concept. I can write it down it as sine 90 degree plus 45. Okay, as there is 90 shift, sine will be converted into cos. And 90 plus means second quadrant, so it will be cos 45 degree. And this is equal to 1 by root 2. Similarly, cos 135 degree, that will be equal to cos 90 plus 45. Okay, so as there is a 90 shift, this will be equal to sine 45 degree. 90 plus means second quadrant. See what is the second quadrant? If I take unit circle, okay, this is 90 degree. So 90 plus, so second quadrant. In second quadrant, sine and cosec is positive, but cos is negative. So it's minus sine 45, that is equal to minus 1 by root 2. Okay, so now let's put down the values. VB, that is equal to 51 into sine 35, that is 1 by root 2, upon VW, that is 72, plus VB, that is 51 into minus 1 by root 2. So this will be equal to 51 upon root 2, upon taking the LCM, that is root 2, 72 into root 2, minus 1 into 51, minus 51. So root 2 will be cancelled. Now let's calculate. Okay, first we will solving 51 upon 72 into root 2. So 72 into root 2, that is 1.414. We are taking it minus 51. So this will be equal to 50.808. 50.8. So 51 divided by 50.8. We will get 1.0039. Okay, now let's find out from the trigonometric table of 10. The value we need to find out is 1.0039. Okay, this is the table for tangent. It's 0 point. We need to find out 1 point. It's 1.0035. This is 70. We want 0039. So I can add this. Or if I take round figure, it's 45. And here is the value, that is 0.0035, that is 45.1 degree. So the angle beta is equal to 45.1 degree. We have taken this as round figure. Okay, so now beta is 45.1 degree. So what is the total angle? Okay, if I just go to this figure of north, east, west, okay, I will get this 45. The resultant vector will be in this way, right? This is the resultant vector. I will write on VR. What is this angle? 45.1 degree. So I need to find out the total angle. It will be this way. Clear? So I can write down it's exactly 90.1, near to 90.1. Okay, I can write down out 25.1 degree from the direction of wind towards east, or I can write down that it's almost towards the eastern direction. So I'll write down that the direction of the flag is almost towards east. Clear? In other words, I can also write down it's making an angle 90.1 degree from north towards east, or zero point 0.1 degree from east towards south. Okay, so this was about 4.14. Just note it down. Now let's move to the next one, that is 4.15. The ceiling of a long hall is 25-meter high. What is the maximum horizontal distance that a ball can be thrown with a speed of 40 meter per second can go without hitting the ceiling of the ball? Okay, now this is related to the question of projectile motion. See now, if I take this as the floor, okay, now and let's take this as the ceiling. Ceiling, this I will consider floor, means from here the ball is thrown. Now see, if you are throwing a ball, let's take this is the point. When a ball is thrown in this direction, this angle is theta, right? Now see, when you increase this angle, okay, when you increase this angle, the ball can reach at different direction, sorry, different distances, right? So our question is that what is the maximum horizontal distance? The maximum horizontal distance you have to find out that a ball thrown with a speed of 40 meter per second can go without hitting the ceiling of a hall. Okay, so now let's take another figure. Okay. This is the floor. Now see, this can be the situation. Ball can be thrown from here in this way. Okay, so this can be the figure. Okay, so this is the maximum distance it can cover without hitting the wall. So this is the maximum height it can reach, and that is equal to 25 meter. The velocity with which it is thrown, okay, its magnitude is equal to 40 meter per second. Okay, now you have to find out this distance, that is called range. So I will use the formula for the range and for the height. Okay, so now what is the formula for the height? The formula for the height, h is equal to u square, or I will say v0 square sine square theta upon 2g. The formula for the range, that is equal to v0 square sine 2 theta upon g. Here this velocity I will say it as v0 because this is the initial velocity. Okay, so now we need to find out the range. We are having value of v0, we are having the value of g as 9.8. We will need to find out the value of sine 2 theta. So what we will do, we will use the formula for height to find out the angle theta. So what is the for height? 25. v0 square, what is v0? That is 40. So I will write down 40 square sine square theta upon 2 into 9.8. So sine square theta will be equal to 25 into 2 into 9.8 divided by 40 square, that is 1600. Okay, so let's calculate it. 25 multiplied by 2 multiplied by 9.8 divided by 40 square is 1600. So that is equal to 0.30625. So sine square theta is equal to 0.30625. Okay, now this is sine square theta, so taking its square root, it's 0.5533. This is sine square theta, so sine theta will be equal to 0.5533. So 0.553, let's take round figure 34. Now we need to find out the value of theta using trigonometric table of sine. So this is the table of sine. We need to find out the value 0.5534. Okay, so let's find out 0. It's 32. Okay, I got 0.5592. So from 33-degree angle, I need to check 0.54550355195534. Okay, I got this value. It's 33 degree. Okay, now 33.0, 1, 2, 3, 4, 5, 6. So 33.6 degree. This is our theta. I'm writing theta is equal to 33.6 degree. Here, so now I can find out the range, that is the maximum distance, that is V0 square, that is 40 square sine 2 theta. So again 2 into 33.6 degree upon G, that is 9.8. So again 40 square is 1600 sine 33.6, that will be equal to 67.2 degree upon 9.8. So again we will use trigonometric table to find out the value of sine 67.2. Sine 67, here it is sine 67, sine 67.0, sine 67.1 and sine 67.2. Means if before point 0, so 0.9219. I will use this value 0.9219. So 1600 into 0.9219 divided by 9.8. So let's calculate 1600 multiplied by 0.9219 divided by 9.8, and this is equal to 150.514. So this is equal to 150.51 meter. Okay, so the unit of velocity and height is in meter and velocity meter per second. So the maximum distance, or I can say the range, is 150 meter. So maximum horizontal distance that a ball covered with a speed of 40 meter per second without ceiling hitting the ceiling of the hall is 150.51 meter. Clear? So this was about question number 4.15. Just note it down. Now let's move to the next, that is 4.16. A cricketer can throw a ball to a maximum horizontal distance of 100 meter. How much high above the ground can the cricketer throw the same ball? Okay, now remember the maximum distance can be attained when the angle is 45 degree. See here, just for example, when you increase this angle, the distance increases. Okay, but after some angle, the distance decreases, right? So the maximum height, maximum distance can be occurred when theta is equal to 45 degree. Then only you can attain maximum height. So here for maximum height, I will write down theta is equal to 45 degree because it's given that the ball is thrown with a maximum horizontal distance because it covers maximum horizontal distance. Okay, and the formula for range, maximum range is V0 square by 2G. Okay, it's V0, sorry, 0 square by G. Now how does this formula? The formula for range is V0 square sine 2 theta upon G. When theta is 45, 2 theta will be 90. When theta is 45, 2 theta is 90, value of sine 90 is 1. Right? So the answer will be V0 square by G. So the maximum range is, the formula for maximum range is V0 square by 2G. You can directly use this formula, right? And that is given here equal to 100 meter. Now the question is how high above the ground can the cricketer throw the same ball? So the formula for height is V0 square sine square theta upon 2g. Clear? So now see, I am just rearranging V0 square by g into sine square theta by 2. Okay? Now we can take value of theta as 45 degree. Sorry, not 45 degree. We'll take 90 degree because see, the question is maximum. Sorry, here how much high above the ground can the cricketer throw the same ball? Means it can achieve maximum height when it is thrown exactly in vertical direction upward. Here, means it is thrown in upward direction and will fall downward. This angle I will take it as 90 degree. So for maximum height, I will take theta is equal to 90 degree. Taking theta equal to 90 degree, the height attained will be V0 square by G. Sine 90, value of sine 90 is 1. So into 1 by 2. Now what is V0 square by G? We already found it out 100. So that will be equal to 100 by 2. That is equal to 50 meter. Okay. Okay, so that was about question number 16. The maximum height that the cricketer can throw the ball is 50 meter. Just note down this 4.16. Now let's move to the next question, that is 4.17. 4.17. A stone tied to the end of a string to 80 centimeter long is whirled in horizontal circle. Means you can take that this is the situation. This stone is tied and this length is zero point 0.8 meters. 80 centimeter means 0.8. Now it is rotated in this way. Okay. So I will take this as a radius of this circle. Okay, it is rotated in horizontal circle. If a stone makes the stone makes 14 revolution in 25 seconds, what is the magnitude of acceleration? Now, when the stone is rotated in this circular motion, its acceleration is centripetal acceleration. Okay, the centripetal acceleration and its formula is v square by r, where v is the speed and r is the radius. So now for speed, what is the formula for speed? Distance upon time, the total path length. So what I will use, the path length. Now 14 revolution in 25 seconds. So 14 revolution. So for one revolution, the path covered is 2 pi r. So for 14 revolution, 14 into 2 pi r, that means 28 pi r. And the time, that is equal to 25 seconds. So the speed, velocity equal to path length, 28 pi r upon 25. Right? So the formula for acceleration v square by r, I will use v square 28 square pi square r square upon 25 and this r. So 25 square and r. So one r will get cancelled. Okay. So now this will be equal to 28 square, value of pi 3.14 square, value of r 0.8 upon 25 square. So let's calculate now. 28 into 28 into 3.14 into 3.14 into 0.8 divided by 25 divided by 25 because it's 25 square. So it's 9.89. So I will write down round figure 9.9 meter per second square. So the centripetal acceleration is 9.9 meter per second square. Yeah, so this was about question 4.17. Just note it down. Now let's move to the next, that is 4.18. An aircraft executes a horizontal loop of radius 1 kilometer with a steady speed of 900 kilometer per hour. Compare the centripetal acceleration with the acceleration due to gravity. Okay, means aircraft is executing horizontal loop. So this is, let's say, the horizontal loop. This is the radius, that is 1 kilometer, or I can write it down as 1000 meter. Okay, when it is moving, this is the direction of velocity at every position. Okay, and the direction of centripetal acceleration, it will be always towards the center. Okay, so formula for centripetal acceleration, that is equal to v square by r. Okay, so now first let's write on given thing, radius r is equal to 1 kilometer, that means 1000 meter. Steady speed, that is v equal to 900 kilometer per hour. So let's convert it into meter per second using shortcut multiply by 5 by 18. Okay, so that will be equal to 18 ones 250. Okay, 18 5 is 90, so it will be 18 into 50. 50 into 5, that is equal to 250 meter per second. So we are having the radius, we are having the velocity. So putting this value v square, that means 250 square upon 1000. So let's calculate it. 250 into 250 divided by 1000. That is 62.5 meter per second square. Now the acceleration due to gravity, that is gravitational acceleration, that is 9.8 meter per second square. So the question is, compare the centripetal acceleration and acceleration due to gravity. Means AC upon AG, that is equal to 62.5 upon 9.8. So divide by 9.8, that will be 6.377. So I will write down 6.38. Let's take round figures. So centripetal acceleration in this case is equal to 6.38 times gravitational acceleration. Okay, so this was about question number 4.18. So just note it down. Okay, students, so that's it for today. In our next video lecture, we will try to complete this exercise. Thank you.